fluorescence, the ones that glow that way, okay? That's different from, for example, phosphorescence, which is glow in the dark. And then radioactivity, okay? How do we determine if something's radioactive? Huh? It'll probably kill you. Actually, no. Almost everything around you is at some level radioactive, okay? And that's because every element has a radioactive form of it, okay? So for example, like there's this really famous video that goes around about bananas, and someone takes a sensitive Geiger counter to the bananas, and the Geiger counter goes crazy next to the bananas, and then they go, see, bananas are radioactive and therefore dangerous. No! What the problem is that potassium-40 is radioactive. All it's saying is that bananas are an excellent source of potassium, because if you have potassium in it, a certain proportion of that potassium is going to be radioactive potassium. So, so most things are radioactive, okay, at some level, usually very, very low levels and amounts. Something with a little bit higher radioactivity we can pick up with my Geiger counter, okay? So we can measure the radioactivity with a Geiger counter. And as an example of that, I just had the sample. Where did the sample? Oh, it probably went to the back table because I passed it around. No, this one isn't one that you guys have touched already. I'm looking for a big pink and green one. Is it up there? Oh, there it is. Excellent. Thank you, Abigail. Everybody's doing rocks right now, so the lab is going into this slow slide into ultimate chaos. So this guy right here, okay, this green mineral in here, it's one of the minerals that's very often brought to my lab as an emerald. It's not. It's a mineral called apatite, okay? And it's six-sided, just like sample 1 is. And if I take a, where did I put my Geiger counter? If I take a Geiger counter, oh, did I put it over here? No, I did not. I can grab a bigger one. But the key is, and I will probably demonstrate to keep the class moving when you guys are working with the minerals, so grab it. But if I put a Geiger counter on this, it'll start clicking. And what that tells me is that this sample is fairly radioactive. It's totally safe, okay? What's going on, apatite itself isn't particularly rich in radioactive isotopes, but what it does is it creates cages that can trap uranium inside them, okay? And that uranium is putting out, relative to the background, fairly high levels of radiation. However, it's totally safe, okay? It's not going to hurt you. You're not going to have superpowers or cancer, okay? So don't worry too much about it. But that's a good example. Apatite is a good example of a mineral where radioactivity can help us identify that it is. Oh, here it is. Ha-ha. So I have my Geiger counter. It was underneath the GO102 binder. That's where it's hiding. If I turn it on there. And that Geiger, those clicks indicate that it's releasing little bits of radiation. So, this guy's already been dropped a few times, so I'm going to leave him up here. So if you're interested in taking a look at the apatite, you are welcome to check it out. Now, you know all the properties. You know how to use them. You have the tools, you have the talent. Ooh. Oh, we were going to do a mineral identification thing, and I don't have the sheet. Let's check the end of the unit. Do we have space on the back? No, we don't. So what I'm going to go ahead and do is I'm going to very quickly run off a couple copies of a mineral identification chart.
Like use these remember there was like markers that were like scented. There was a black licorice one. Everyone hated it.
Oh yeah. I was gonna say you love that one.
Well,
okay.
I love them.
That's a hat, probably.
Were you that kid that like all her crayons had to be in a specific order?
Yeah.
I had to get all the twisted ones.
Well, like, actually, I'm surprised that they're not in, like.
In order now.
Yeah. Careful,
You
she'll
wanna
lick it.
smell
You
it?
can smell it.
One time. One time.
The nostalgia is real.
One time. Okay, you lick it. Lonnie was that kid in class who like ate crayons.
Yeah.
That wasn't sand, paint, glue sticks.
Mhm.
Yeah. Or no, putting the glue on your hand and letting it dry.
Oh my god,
and
yeah,
then
I did
feeling
that.
I always do that. Whenever
Yeah.
there's like an art project for my brother, I was like, oh, you can't handle the glue. And then just wait for it to dry. And my mom's like looking at me, like, I'm like,
Went in too quick.
I know. I was that kid. That was me when I had like the markers. I'd be like, like
At least I've never eaten a crayon.
That we know of.
that we know of.
I've never eaten a crayon.
So it's funny that, you know, we've been perfectly fine in the notes up until this point, but as soon as I grab
You know what's funny? Honestly, to me, these.
and it turns out that my office
Yeah,
mate
we
used
should
less
go.
paper. So we're gonna put a pin in that and do our mineral identification
Yeah.
on Friday, which is fine because first two things. Number one, it'll be a good relaxing thing going into Monday. And how many classes do we have next week? One,
Yeah.
right? We only have Monday class, okay? So Friday will be a good cool down. We'll explore our minerals. And the other awesome thing is now we can leap and go straight into what? Rocks.
That's funny. So it's just confusing.
Ah, the one time, first time I have a camera. That's the first time. Now it's recorded forever that there was a missing page in the notes and that like never happened. Hasn't happened the whole semester. Camera comes out, here it goes. Oh well.
Yeah, like,
Such is
You
life.
got it.
So let's rock some rocks. Okay, we'll do this as the last few bits up until the end of class. Okay, now we've already talked a little bit about what makes a rock. We've already built part of that definition. What is a rock? A rock is what? Accumulations, I got sediment. We're thinking of sedimentary rocks. What? A naturally occurring solid. Excellent. So a rock is a naturally
Maybe not.
occurring solid. So a reasonable question is, what's the difference between a rock and a mineral?
Doesn't have all 5 elements.
It doesn't have all 5 elements. So a rock doesn't have to be, but a rock can be what that a mineral can't?
A liquid? No.
No, because it's a naturally occurring solid.
No.
I know. You know, it's been one of those days. I was standing on the elevator pushing angrily, like, why isn't the elevator moving? I was pushing up and I was already on the top floor. So we're all having a Wednesday.
That's like something
Yes.
I would say. That's all.
Organic. So a rock can be organic. What else can a rock be?
No.
Excellent. Indefinite formula or indefinite composition. In other words, no formula. Can have an indefinite. Part of me was like, the grammar hurts. So can have, now we're parallel. And what's the other thing it can have? What's the other thing it can be or can have that a mineral cannot? It doesn't have to have a crystalline structure. So it can be a glass or non-crystalline. Well, minerals cannot. Now there are rock names and mineral names. Even when you're dealing with a rock that's almost purely that mineral, it will have a rock name, and then when you talk about the mineral and the rock, that will have a mineral name. An example of rock names versus mineral names. Marble is a rock that is almost pure calcite, which is the mineral. Okay? So on the test, if I ask you a question about is this a rock or is this a mineral, don't get mistaken and say like, well, that's a rock that's purely that mineral. No, there's rock names and mineral names. Okay? So when we find calcite in a particular form, in a particular context, we would call it marble. Okay? Even though marble is pretty much just 100% pure calcite. Does that make sense? A little bit of sense? That we have rock names and mineral names and they're separate from one another? You're looking at me. So
Can you
one
explain
person's nodding their head. Yes, Brittany.
Can you explain it one more time?
Can I explain it one more time? Yes, so we have rock names and we have mineral names. Sometimes a rock will be purely one mineral, like marble is a good example. But the name of the rock, when I ask you about rocks, is marble. The name of the mineral in the rock is calcite. Make a bit of sense? Excellent. Okay. So, some of you trusted me on exam 1 when I said this is going to be on the exam. Some of you, what was going to be on the exam? You knew it. What had to be on the exam is also going to be on the final. Unit 1, huh? Our names.
Our names.
Our names. Your name. Actually, I would take it without your name. I just try to find the person it attached to. My classes aren't so big where that's a huge logistical thing. No, what's the one question I was like, you're gonna know this. It's gonna be on the test. Unit 1, meteorology and oceanography, if that helps.
The water cycle?
Huh?
Different kind of cycles. The difference between weather and climate.
That's a good thought. Remember, and it's going to be on the final too, the seasons, right? I told you that how the seasons work. I'm going to test you on the next exam, I said. And then I said, it's going to be on the final. And some of you trusted me. Now, this is your opportunity to demonstrate that again. And for those who didn't trust me, it's a chance to redeem yourself. Because the rock cycle will be on the exam. It's not... Very often I will say likely on the exam. This will be on exam 4 and the final. And that's a lot of points because each short answer on a regular exam is worth 6 points, right? And on the final, it'll be worth 9 points. So if you just memorize this, that's 15 points, okay? Take the time to memorize this. So the rock cycle is basically how each rock type becomes every other rock type. And that's the take-home message. That's what we're trying, that's what I want you to be able to express and demonstrate with the rock cycle. So there are 3 major families of rocks. Yeah. What are those 3 families of rocks?
Igneous.
Igneous.
Sedimentary and metamorphic.
Excellent, Leilani. So we have igneous, metamorphic, or sedimentary, and metamorphic. And just because, I mean, you could have metamorphic up here, it doesn't matter, or igneous over here, doesn't really matter. But just getting used to drawing it, this is how I usually draw it, and it might be a good way for you to practice is to always draw the same diagram, okay? So, these are 3 words. If you went to high school here in the great state of New York, you have seen these words before because you went through earth science, huh?
Several times.
Several times, exactly.
Preached with it because it had to be in the Regents exam.
Exactly. So, does anyone know the definition of any of those 3 types of rock?
Igneous is melted rock below ground.
Oh, doesn't have to be below ground.
It's just melted rock.
It's just melted rock. Excellent. So, igneous rock forms from melted rock. So if I put in the middle here, melted rock, how do sedimentary rocks and metamorphic rocks become melted rocks? This is an easy question.
Melting.
Melting, excellent. They melt and they melt. Now, how do we go from hint, hint, liquid to hint, hint, solid rock? What's the process of liquid to solid? Freezing, excellent. Was that you, Brittany?
No.
Leilani again? Good job. So we got a definition for igneous, and now we've got the arrows for igneous, and that's how it goes along, okay? What I want in the rock cycle is showing that each of these rock types, both of them can melt and end up as an igneous rock. All the rock types can become each of the other rock types. Now, does anybody know the definition for any of the others? Liquefaction, what's that? Yeah, the book's rock cycle is super duper complicated, and I do not make people memorize that beast. But you can still glance at it if you're looking for words. Right now I'm just looking for the definition of sedimentary or metamorphic rock. Yes, Leilani.
Sedimentary is formed by the byproduct of weathering.
Excellent. So sedimentary rocks are from the byproducts of weathering, or you can just say from weathering. Either one of those work. Now the reason we don't just say it's made from sediments, it's right there in the name sedimentary rock. Not all sedimentary rocks contain sediments. Only one class, there's 4 classes of sedimentary rocks, and only one of those classes actually contains sediment. So, how do you think we get from an igneous rock and a metamorphic rock to a sedimentary rock based on that definition? Yeah, weathering. Yep, this is not supposed to be stressful or complicated. Excellent. Now, we're just left with metamorphic. I know Leilani knows it. She knew the other 2. So, does anybody else know metamorphic? I know you. Talk to your neighbor.
It's heat and pressure, but not melting.
Ah.
But not melting. It's because of the homework.
Because of the homework! Excellent! I love hearing that. Leilani's like, of course I know it. It's in the homework. That's a good thing to hear. So, what is a metamorphic rock?
I just said it, come on.
Be bold! Who's got it?
Heat and pressure.
Heat and pressure. Clarify.
Yes.
See? I only got
But
heat
not
pressure.
heat it up and then it pressure.
So rocks under heat and pressure, or pre-existing rocks. Pre-existing rocks under heat. Why did I put an E on that? Under heat and pressure. So, this is the did you drink enough coffee before coming to class question. How do I get from igneous and sedimentary to metamorphic?
Heat and pressure.
Heat and pressure. So this is what you should be able to draw. But where did we get the arrows from? What told us what the arrows were labeled? Where did we get that from? So for each of the rocks, I once we had something set up, I then was like, so what should be on this arrow? And you knew it. Where did you get what you knew? From the definition of the rock. Excellent, Abigail. So a good place to start is with these definitions. Okay? So if you start memorizing the definitions, then you know, okay, when I'm going from sedimentary to metamorphic or igneous to metamorphic, that's heat and pressure. Okay? So start by memorizing the definitions, and then the chart just comes out of it. Because I think what a lot of people do is they start with the chart and then follow it up with the definitions, and then that leads to arrows everywhere and messiness. Okay? So, any questions about this? This is not kind of going to be on the exam, or maybe going to be on the exam, it's going to be on the exam. This is a gonna be thing. So, huh? Flashcard, exactly. That's another thing I like to hear. This is a great flashcard topic. So, we just talked about it. Rock formed by cooling from a melt. In other words, melted rock. What kind of rock is that? Igneous. Now, igneous, melted rock can be above ground or melted rock can be below ground. Does anyone know what the names of those melted rocks are?
Magma.
Magma and lava. Which one's magma, which one's lava?
Lava's above.
Lava is above. That's the thing that comes out of a volcano and runs over the surface. And then magma is the one underneath it. I think we're going to actually manage to get through a brief intro to igneous rocks today. So, igneous rock freezes at high temperatures. What do we mean when we say freezing? Excellent, turns into a solid. So we go from a liquid to solid. And that can happen at about 1100 degrees C to 650 degrees C, depending on composition. In other words, somewhere in the neighborhood of around 2000 to 1200 degrees Fahrenheit. Now, just like melted rock can be two places, frozen rock can be two places. You can have igneous rock forming above ground, or you can have igneous rock forming below ground. So, if an igneous rock cools quickly at the surface, what's that called? People who may have done the homework already. Extrusive, excellent. What about cooling slowly at depth? Intrusive, excellent. People are doing the homework. Now, the two most important igneous rocks, at least when we're having a conversation about geology, are granite and basalt. Where do we find granite and basalt in Earth's system? Haven't really talked about the crust yet. Okay? Both of them are part of the crust. Where do we find more granite in the crust? Where do we find more basalt? Maybe someone who's been reading along in the homework. No volunteers? That's okay. Homework's not due yet. So if you're not at that part in the homework, that's fine. So both are part of the crust, so granite and basalt. Make up the crust. And we'll talk about that more when we talk about plate tectonics. Granite is continental crust. Basalt is oceanic crust. Now we'll do a little bit of a review, go back over extrusive and intrusive igneous rocks, because you will be able to identify these by the end of Friday class. And we'll also do the minerals activity as well. You go through, build a mineral chart, and that'll be a nice, hopefully a fun and relaxing way to move into Thanksgiving week. So if anyone has any questions, let me know. And just so you know, today is the Thanksgiving luncheon for the faculty. So I usually have office hours right now, but I don't today, okay? Because I'm going to go eat, not turkey, but something vegetable related to the turkey. So, and I hope you guys have a nice afternoon.
Should we just leave this stuff here, or do you want to up front?
Yeah, go ahead and leave that, pack up your mineral kits, and as long as those are packed up and with your trays, that's good. You can just leave that there, and I will collect it. And hopefully they will have coffee at the luncheon, because I dressed up and I need to go downstairs. So obviously I haven't had enough today.
Yeah.
And I'm just going to sneak behind you and turn off the camera.